Hello, my dear students and the rest of the learners. Welcome to this presentation in which I will be looking on the topic system development. This is part 4 of a 4-part series of presentations in this topic, with the title of this presentation being the stages of system development, with the focus being on system implementation, system maintenance and review, and system documentation. My name is Meme JM, or you can simply call me Emily Swap. Therefore, the content of this presentation is system implementation, the system maintenance and review, and system documentation. Let's commence by looking at system implementation. System implementation is the process of delivering the system for use in day-to-day environment for the users to start using the system. The areas addressed during this phase include file conversion, staff training, and changeover strategies. It generally involves the preparation of an operational environment and installing the new system in the user's computers, providing training for users, information system staff, and managers, carrying out file conversion and system changeover, carrying out a post-implementation evaluation of the system, as well as presenting a final report to the management. The operational environment. The hardware and software environment for the actual system operation is called the operational environment, while the environment that the analysts use in order to develop and maintain a program is called a production environment. The following are some points that you should put into consideration when buying or releasing the hardware. Number 1, if some computers have already been acquired, additional units need to be compatible. Number 2, the minimum amount of main memory to satisfy the processing requirements must be established. Number 3, if processing will involve extensive mathematical calculations, special math coprocessor chips may need to be installed in some computers. Number 4, the video display units will need to be of high resolution for certain applications such as graphics. Number 5, the storage requirements should be carefully analyzed in order to determine what size of the system to purchase. Number 6, the quality, volume, and type of printed output to be produced must be considered in determining the type of printers required. Number 7, determine the delivery schedules for all the equipment. Number 8, determine where the hardware should be installed. Number 9 is to determine how many users the system will need to support now and in succeeding years. Number 10 is to determine the amount of multi-users and multitasking that will be required. Number 11 is determine the type of operating system that will ensure program compatibility and efficiency. Number 12, determine computer communication needs. Once hardware needs have been identified, the organization or the company must then determine which vendor to choose. Some considerations to keep in mind when deciding on the vendor include, number 1, the financial stability of the vendor should be strong. You want the vendor to be in business when you call for assistance. Number 2, the vendor should have a qualified technical support staff for ongoing maintenance and repair with free 12 lines. Number 3, the vendor should have staff available to assist in setting up the equipment and also make sure that the equipment is ready to operate. Number 4, the vendor should have staff available to provide training in the use of the acquired equipment. What about when it comes to file creation and conversion? File conversion is the process of modifying or changing the format of the existing data files from manual to electronic form, that is computerized form, in the new system. A new computer-based system cannot be used until all the data files are converted into computer usable form. When a system is computerized, file conversion can become a monumental task. This is because the time and the effort required to sort through and key in the data and the corresponding cost of doing it are great. Outside assistance may be required for large file conversion tasks. If an existing computer-based system is being changed to a new system, the files can be converted by a computer program. It is important to put in place measures to verify all the data, correct all errors, and ensure completeness of records. The main factors to consider during file conversion include, number 1, whether the new system requires a new operating system and hardware. Number 2 is whether you need to install new application software. Number 3 is whether you need to create new database files for the new system. A system is said to be data independent if it can be changed without affecting the organizational data structures in the database. Therefore, file conversion is the process of transforming, modifying, or changing the format of existing data files to a new computer format in order to be usable in the new computerized system. The stages of file conversion will depend on the method that is currently used for keeping the files: manually, in box files, or magnetic tape, but are likely to be, number 1, production of control totals. Number 2, transcription of all standing data. For example, account number, address, etc., to a special input document that is designed for easy data entry. Number 3 is insertion of all the new data required onto input document. For example, account numbers where some were used previously. Number 4 is transcription of data from documents to magnetic media. Number 5 is verification of transcribed data. Number 6, data is then used as input to a file creation run. A specially written computer program procedures the master records in the required format. Number 7 is printing out of files for comparison with the old files. Number 8 is printing out of control totals for agreement with the playlists. Number 9, at a date immediately prior changeover, variable data is inserted in master files. For example, balance on accounts. What about when it comes to staff training? What is supposed to be done? A staff training is the process of equipping the system users with thorough knowledge on how to use or operate the new system. The amount of training required for various categories of personnel will depend upon the complexity of the system and the skills that are presently available. The systems analysts will be required to ensure that all the persons involved in the new system, for example, users, managers, and information system staff, are capable of making the process an operational success. The process of training involves the use of the following aids. Number 1 is use of handbooks. These are produced from the system specification and they are used for reference. Therefore, they must be available when needed. Number 2 is short courses. The users can undergo through continuous short course trainings, especially the in-house training, in order to help users adjust to the new system. Also, either full-time or part-time courses, often run by the computer manufacturers, can be used. Number 3 is lecturers or lectures. Through the lectures, the analyst can take the users through a general background of the system by equipping them with the general background knowledge or knowledge of specific areas in relation to the system. And this is important for the users. And therefore, through lectures, the analyst can cover general background, can equip the users with the general background knowledge or knowledge of specific areas in relation to the system. Number 4 is use of workshops. The workshops are necessary as part of the training process where the users will attend a 1 or 2 days workshops that can be conducted by experts who will be doing demonstrations on how to use the new system effectively. These experts are usually the owners of the software that has been implemented in the new system. System implementation can fail if the staff are not trained properly, thus leading to great loss of company resources. The availability of appropriate documentation, like user manuals, makes staff training easy, quick, and effective. The training aims at the following. Number 1 is convincing the staff of the user department on the effectiveness of the new system. Number 2, The training helps remove fear from the members or from the users in relation to the change that is expected from them. Number 3, the training enables the staff to be able to cope with the processing tasks of the new system. Some examples of the training needs of the different users include, number 1, when it comes to the ordinary users, they need to be trained on the key terms, the startup and shutdown of the system, the main menu and submenu, the icons and shortcut keys, the major reports and displays, online and external help, the frequently asked questions, troubleshooting guide, as well as handling emergencies. On the side of managers, they need to be equipped with knowledge and information in relation to system overview, the project design, the cost-benefit analysis, support for business goals, the key information system contact people, handling system changes, how to request for system enhancement, as well as user training. On the side of the informational system staff, they require information in relation to the project history and its justification, the system architecture, system documentation, frequently asked user questions, as well as vendor support, which include problem logging and resolution. Some methods that can be used when it comes to training include demonstration, use of film shows, manual references, group decisions, as well as visits. Let's now look at changeover. Changeover is the process of moving from the old system and starting to use the new one. The 4 main methods or types of changing over that can be used include direct or straight changeover, the parallel changeover, phased changeover, and piloting. What is direct changeover? Direct changeover is when the old system is stopped, halted, or discontinued abruptly, and the new system is installed and becomes operational immediately. This sudden change of old to new system makes the system face problems because the old system would not be there to fall back in the case of challenges or problems. This approach is most often used for small systems or large systems for which a systems model was previously developed and thoroughly tested. Simply halting the old system and starting up the new system is a very simple approach. However, the method carries some risks. The main features of direct changeover include, number 1, if the new system bears no resemblance to the old system, then a direct changeover is possibly inevitable. Number 2, there must be complete confidence in the new system's reliability and accuracy before the method is used. Its main advantage is that it's cheaper because you do not have to run the 2 systems in parallel. However, it carries with it the following disadvantages. Number 1, it is extremely risky to implement such a method of adapting a new system. Number 2, it places an organization in a do or die situation because anything can happen. Let's now look at parallel changeover. This is where both the new and the old systems are run concurrently for some time with the same inputs until the users have confidence in the new system, and then the old system is phased out. The outputs are compared and the reasons for differences are resolved. The outputs from the old system continue to be distributed until the new system has proved satisfactory. At this point, the old system is discontinued and the new one takes its place. This approach is the safest because the operations do not have to be shut down if the new one has problems. However, it is by far the most expensive and difficult approach to coordinate. The main features of parallel changeover are: number one, it is a costly method because of the amount of duplication that is involved. Number two, this method would mean that the employment of staff is extra, or overtime working will be required for the existing staff. This can create difficulties over the period of changeover. Number three, it is only possible where the outputs from the old and the new systems are easy to reconcile and where the systems are similar. Number four, its use does not give management the facility of fully testing the new system while still retaining the existing system. I repeat, the use of this method gives the management the facility of fully testing the new system while still retaining the existing system. This changeover method is quite expensive because it requires more staff to be hired in order to operate the two systems. That is, the staff to operate the new system as well as the staff to continue operating the old system. Also, extra resources are required to run the two systems. Its main advantages are: number one, it provides a method of training in the new system. Number two, the personnel become familiar with the new system before the actual changeover. Number three, it has lower risk to business operations and the thorough testing of the new system is done. However, it carries with it the following disadvantages. Number one, operating the two systems instead of one system takes a lot of time and effort. Number two, comparing the output from the new system to the old system and evaluating the results takes a lot of time because a lot of cross-checking is carried out and it is difficult. Number three, it is quite expensive as it requires more staff to be hired in order to operate the two systems. Number four, it is not suitable for large systems because of the high operational costs that are involved during the changeover. The third method is called phased changeover. This is a situation where the new system is implemented in stages. Some systems are too broad in scope or are too large that they must be implemented in phases in order to avoid the traumatic effect of trying to implement all the components at once. The implementation is more easily handled one phase at a time. Once they are running, the whole system is then implemented. So, in phased changeover, the new system is gradually introduced. That is, department by department, until the whole organization gets computerized. However, its main disadvantages include, number one, there is danger of incompatibility between various elements. Number two, there are problems that arise when ensuring that the first phase is implemented and converted. However, its main advantages are, number one, it ensures that there is a slow but sure changeover. Number two, it allows the new system to be implemented quickly. Number three, it is less costly in comparison to the parallel one. Number four, in the case of failures, those failures are limited. Number five, it causes minimal disruptions to the operations of the organization. The fourth method of adopting the new system is the piloting changeover method. This is changing part of a system or running a new system for testing before it is implemented into all the other phases. If a system is to be implemented at many locations in a widely dispersed company or organization, the task can be very difficult to manage all at once. To implement the system at one location at a time and ensure that it is working correctly before moving on to other locations is usually a safe way. And this is called pilot implementation. The main feature of pilot changeover is that it uses, or it is a variation of the parallel and direct methods because it enables the system to be treated as a separate entity. And therefore, the main feature of pilot changeover is the use of variation of the parallel and direct methods. For example, a department or a branch might be computerized before the undertaking as a whole. And therefore, the use of the variation of parallel and direct methods is possible when a part of the system can be treated as a separate entity. Let's now look at security control measures. Information and data security is a very important aspect of an information system. Therefore, a lot of careful planning has to be done in order to have an inbuilt security in the system. This is because information is under constant threat of being illegally accessed or undisclosed to unauthorized parties. Therefore, the system implementers must make sure that the security features built in the system are properly configured during the implementation stage. Let's now look at system maintenance and review. System maintenance is the adjustment and enhancement of requirements or a correction of errors after the system has been implemented. This is because errors may be detected when the system is in use. The system review is a formal process of going through the specifications and testing the system after implementation in order to find out whether it still meets the original objectives. This act is sometimes called review and audit. The system review is actually the process of monitoring the system in order to ensure that its reliability, which is routinely carried out throughout the life of the system, is still okay. The new system is reviewed against the original system objectives. If the new system does not meet the stated objectives, the system development might start all over again. Some events that can trigger system maintenance include, number one, changes in business policies. After the implementation of the new system, new policies may have been introduced since the implementation of the new system. Number two are changes in customer demands. The users of the new system may require additional features such as inputs or outputs. Some of the necessary features may have been overlooked during system design, which may now become necessary amongst other demands. Number three is availability of new technology. When a new and better hardware or software emerge, there may be need to review the system. So, when new and better hardware or software that is much better than the previous one emerges, including emergence of new and better storage facilities that are more secure, then there may be need to review the system. The system will need to be maintained and revived for the following reasons. Number one, to deal with unforeseen problems arising in operation. For example, programs may need to be modified in order to deal with unforeseen circumstances. Number two is to confirm that the planned objectives are being met and to take action if they are not. Number three is to ensure that the system is able to cope with the changing requirements of business. The system is reviewed for the following reasons. Number one is performance review. The new system is evaluated against the old system, that is the current system. It must be better and more efficient than the old system. Number two is time. It's reviewed in order to make sure that the time estimated for each development phases for various parts match the actual time it took to complete the whole project. This is important as a reference in the development of similar projects in the future. Number three is cost review. During the planning phase of the development, cost estimate was assessed. Now, it is time to review if the actual cost matches the cost estimate. If not, a further analysis of each phase may be necessary for the adjustment of the estimate of future projects. Number four is customer specification. The success of a new system is usually measured in terms of satisfaction of the customer, who is the user of the system. It is important to evaluate the satisfaction level of the customer because high satisfaction may indicate the quality and the correctness of the new system. Low satisfaction, however, indicates an opportunity to make some necessary adjustments in the system. Number 5 is fault tolerance. The quality of the system also depends on how it tolerates and corrects errors automatically, and should be easy to modify the system should the need arise. The maintenance of the system may span several years, during which time the changing requirements of users lead to minor modifications to the system. It reaches a point whereby the cost of maintenance becomes extremely high. Therefore, the management can sanction the start of a new system. Some maintenance activities include changing programs, procedures, or documentation in order to ensure correct system performance, adapting the system to changing requirements, or making the system operate more effectively. So, the 3 main types of maintenance are: number 1 is what we call corrective maintenance. In corrective maintenance, it diagnoses and corrects errors in an operational system. It calls for careful analysis before making any changes in order to avoid introducing new problems, preferably using a scaled-down version of system development lifecycle. It also calls for standard procedures for error response, whereby a user submits a system request. That request is evaluated, prioritized, and scheduled by a system review committee. If approved, maintenance team designs documents and implements a solution. If a major error is reported, documentary evidence is required and the problem is allocated a high priority. In case there is a total system failure, maintenance bypasses all the initial steps outlined above and tries to correct the failure immediately. The second type of maintenance is called adaptive maintenance. In this process, or in this maintenance adds enhancements to an operational system. An enhancement is a new feature or capability that improves efficiency or maintainability. Therefore, the purpose of adaptive maintenance is to add certain enhancements to the operational system. The need for adaptive maintenance usually arises from business environment changes, such as new products and services, new technology, amongst others. An adaptive maintenance project is like a small-scale system development lifecycle project, but it is more difficult than new systems development projects because the enhancements must work with the constraints of the existing system. It is often triggered by user requirements. The third or the other type of maintenance is called perfective maintenance. This involves changing an operational system in order to make it more efficient, reliable, or maintainable. This can be done at both software and hardware level. It may include, number 1, adding more RAM or random access memory to improve the system performance. Number 2, increasing the network speed and bandwidth in order to improve performance. Number 3, writing macros to handle repetitive tasks. Number 4 is migrating the system to another development platform that is much better. For example, object-oriented programming. During system operation, changes in user activity or data patterns can cause a decline in efficiency, and this calls for perfective maintenance in order to restore the system's performance. Apart from improving efficiency, it can also improve response time and system reliability. The 2 techniques that can be used in perfective maintenance include: number 1 is reverse engineering. This is a case tool that translates program source code into a series of logic charts, structure charts, and text description that allow analysts to study the program from a design point of view rather than from a coding level. Number 2 is re-engineering. This is a case tool that the analyst uses interactively to correct program errors or change program design, in addition to suggesting coding modifications to improve a program's quality or performance. Let's now look at performance and workload measurement. The parameters such as number of records accessed, number of transactions processed in a specified time, amongst others, can be used to measure the workload of the system. Performance is usually measured in terms of the response time. The response time is the overall time that is taken between a request for a system activity and the delivery of the response. The response time includes 3 elements. These 3 elements are: number 1, the time necessary to transmit or deliver the request to the system. Number 2 is the time taken to process that request. Number 3 is the time taken to deliver the response. Some parameters that are used to measure response time include the system turnaround time and the system throughput. The system turnaround time is the measure of the efficiency of the central computer operations. It is the time that is taken between the arrival of the request from the user at a computer center and the availability of the response or output for delivery or transmission. When it comes to throughput measures the efficiency of the computer itself or the system itself. This is the time from the input of a request to the central processor until when the output is delivered to the system. Throughput can also refer to the efficiency of a data communication network. The performance evaluation needs to be done after any changes are made to the system or the business information requirements have been changed. Performance data are also used for cost-benefit analysis or proposed maintenance and to evaluate the systems that are nearing the end of their productivity lives. Management also uses the current activity and performance and workload data in capacity planning. Capacity planning is a process that monitors current activity and performance levels anticipates future activity and forecasts the resources needed to provide required levels of service. What is system obsolescence? A system becomes obsolete when its functions are no longer required by users or when it can no longer support the business needs of the organization. A system that has reached the end of its economic life, hence ready for discontinuation, is indicated by, number one, steady increase in adaptive and corrective maintenance. Number two is operational costs or execution times increasing rapidly, and routine perfective maintenance does not reverse or slow this trend. Number three is where or when a software package is available that provides the same or additional services faster, better, and more cost effectively than the existing system. Number four is when new technology offers a way to perform the same or additional functions more efficiently. Number five is when maintenance changes or additions are difficult and expensive to perform. Number six is when users request significant new features to support business needs. Post-implementation evaluation assesses the overall quality of the information system. This involves verifying that the new system meets specified requirements, complies with user objectives, and achieves the anticipated benefits. It also helps improve information system development practice for future projects. It's conducted by people not directly involved in developing the system. Let's now look at system documentation. Documentation is the process of keeping or maintaining a complete historical record from the system's inception through different stages of development to the last stages of maintenance and review. System documentation is a written record of the steps taken during the system development process. It's therefore a lifelong process in the system development lifecycle because it's supposed to be done from the first stage all the way to the last stage in system development. After a system has been implemented, any maintenance work must be documented in order to update the existing documentation. The documentation serves as a guideline to whoever that wants to know the details of the system in place. It includes or involves the following. Number one are reports on fact finding. Number two are the requirements specification. Number three is the system and module flowcharts. Number four are the table or file structure descriptions. Number five is sample test data and expected outputs. Number six are the output reports. Number seven are the user manuals. When it comes to documentation on the reports for fact finding, this report is prepared by the analyst at the end of fact finding stage, and it outlines the following: the methods used to collect the data, the problems encountered in this exercise, the weaknesses of the current system as evidenced by the collected data, the recommendations with respect to the system maintenance, why there is a need for a new system or upgrade of the current system, amongst the others. On the requirements specification, the report outlines the following: the output requirements for the new system, such as reports, the input requirements, the hardware and software required to develop the new system. On system flowchart, the report shows the overall functionality of the proposed information system, or the documentation shows the overall functionality of the proposed information system. So, at the end of the design phase, the system analyst must write a report that contains the system flowchart or data flow diagrams that shows the processing logic of the information system, any module flowchart that may help programmers in the construction of the required subsystem or modules. On table or file structure description documentation, depending on the approach used in the system construction, this report should contain file or table structure definitions. For example, if you opt to construct a system using customization approach, details on how table structures should be are done should be well documented. For example, indicating field names, data types, properties, descriptions, and primary keys. The report of the system should therefore have the following information: the structure of all the tables, including the keys, such as primary keys associated with each record in the table, full description of all tables maintained in the new system, the data types of the fields used. On sample test data documentation, to test whether the new computerized information system is working as expected, you need to use test data for every module or subsystem. And therefore, records should be used showing an entry for each field in the table that is being tested. When it comes to output reports documentation, in order to prove that the system is working and giving the desired result, you should provide a number of sample output from the various system modules. On user manual documentation, this is a documentation that is used by the system users to be able to use or operate or work with the new system with as little guidance as possible. To ensure the smooth running of the new system, the system analyst works with the users to develop a user manual that is going to be maintained, provided that the system is in operation, including online help and the websites that would feature frequently asked questions. The user manual assists the users on how to operate the system and what to do in case of problems. The user manual contains the information such as, number one, how to install, start, and run the system. Number two, how the system appears when running, that is the interface. Number three is how to carry out various tasks. Number four is error correction and how to get help when faced by exceptions. This would be in troubleshooting guide. Some reasons why documentation of a system is necessary include, number one, it's necessary for the continuity of the project if it had been stopped at some point before completion. Number two, should the programmer who designed the new system leave the organization, the incoming programmer can easily follow the documentation and understand the system easily. Number three, precise documentation aids in the modification that may be necessary. With that, we have come to the end of the topic on system development. Congratulations, my dear students and the rest of the learners, for learning part 4 of 4 on system development. You can now access part 1 to part 3 of this series and more computer or ICT videos by clicking or tapping on MLSwap ICT YouTube channel button below this video. You can also subscribe to this channel by tapping on subscribe button below this video if it's not currently reading as subscribed. You can also visit and subscribe to MLSwap Life Skills YouTube channel for free life skills, motivational, and inspirational resources. For any further correspondence, kindly write it to us through the email mlswap@gmail.com. Thank you very much for listening to me, and God bless.